All right, starting section 6.1, inequalities in one triangle. Now, the side opposite of the largest angle, all right, here's the largest angle. The side opposite to it, that would be the longest side. All right, and the side opposite of the smallest angle, here's the smallest angle, side opposite to it would be the shortest side. Okay? And now the angle opposite of the longest side, here I have the longest side, the angle opposite to it would be the largest angle. And the angle opposite of the shortest side, here's the shortest side, angle opposite of it would be the smallest angle. All right, example 1, list the sides in order from shortest to longest. All right, the sides. All right, well, before I could figure that out, I have to figure out what all the angle measures are. So here I have 50 and 95. So measurement angle C plus 50 plus 95. All the angles of a triangle add up to 180. Okay. So the measurement of angle C is going to be 35 degrees. Okay, 35 degrees. All right, and they want me to list the sides in order from shortest to longest. All right, shortest would be across from the 35-degree angle. That's going to be AB. All right, and then the next one up is 50. So the next side length, BBC. And then I have 95. The side across from it is AC. All right, there we go. The sides are listed in order from shortest to longest. All right, for part B, list angles in order from smallest to largest. Okay, we have the smallest side here. So D would be the smallest angle. Then the next side length up is 5. So E would be the next angle. And then I have 6. So F would be the largest angle. That's all there is to it. Done. All right, the triangle inequality theorem. The sum of the lengths of any two sides, of a triangle is greater than the length of the third. All right, so you could take any two sides, their sum, and it should be greater than the third. Okay. Now for example 2, all right, and these are the 3 scenarios you could come up with, all right, because you're adding 2 different pairs for every one of these scenarios. Example 2, is it possible to construct a triangle with the given side lengths? Very important. You only have to use part of the triangle inequality theorem, part of it. All right, to solve this type of problem, if the sum of the two shortest side lengths, is greater than the third, then a triangle can be constructed. All right, let's take the 2 shortest sides, 3 plus 3. Is that greater than the third? That's false. All right, so your answer here is no. For part B, we have 6 plus 6 is greater than 12. 12 is greater than 12. Is that true? No, that's also false. They're equal, but 12 is not greater than 12. So the answer here is no. How about for the next one? We have 9 plus 5 is greater than 11. Is that true? 14 is greater than 11. That is true. So a triangle can be constructed using those lengths. All right. Example 3. A triangle has one side of 3 centimeters and another of 14. Describe the possible lengths of the third side. Okay, we don't know what the third side is. We'll call that X. All right. Now there's 3 different scenarios you're going to set up here. If you look back to the triangle inequality theorem, I'm going to have 3 plus 14 is greater than X. That's one combination. I could have X plus 3 is greater than 14. And I can also have x plus 14 is greater than 3. All right, so we have 17 is greater than x. X has to be less than 17. All right, here I subtract 3. X has to be greater than 11. And here I subtract 14. And I get a negative length, and I don't need to use that information because I can't have a negative length. All right, so combining these two pieces of information, what's the smaller number? 11. What's the greatest number? 17. All right, x goes in between, and I'm combining these two inequalities into one, so both of the arrowheads should point to the left. Okay? And that's my answer. Or if I want to be more specific, I could say centimeters here. All right, so the side length with a triangle with these two lengths, all right, the third side length has to be between 11 and 17. Let's go on to another example. All right, in the figure below, n is a whole number. What is the smallest possible value for n? Okay, let's come up with all the different scenarios here. Then I have 15 plus n is greater than n. And I could rewrite the same thing again, but I would just be repeating myself. So here if I subtract n just disappears, and that doesn't help me at all, so I don't need to use that information. This is the key setup here that's going to help me answer the problem. So I have 2n is greater than 15, divide by 2, and n has to be greater than 7.5. Okay, that's your answer. Or you could just say 7.5. All right, cannot be any less than that. All right, in the figure below, n is a whole number. What is the largest possible value for n? All right, I'm going to have a couple different setups here according to the triangle inequality theorem. Then I have n plus 5 is greater than 12. N plus 12 is greater than 5. Okay, so here I have 17 is greater than n, or n is less than 17. Here I subtract 5. I have n is greater than 7. All right, these are key pieces of information right now. All right, for this one I get a negative number. I don't need that information. All right, so n has to be between 7 and 17. Answering the question, what is the largest possible value for n? That would be 17. All right. Done. Let's do a couple more examples. Example 5, the lengths of two sides of a triangle are known. Which of the following could be the perimeter of the triangle? Okay. Well, let's first figure out what the possible lengths for the third side can be. So I'm going to call this x. So I'm going to have 7 plus 12 is greater than x. I have 7 plus x is greater than 12. I have 12 plus x is greater than 7. All right, so here I have 19 is greater than x, or x is less than 19. Here I subtract 7, and x is greater than 5. Subtract 12. All right, don't have to use that because that's a negative value. So x is between, let me use a different color here. Okay, so x is between 5 and 19. Okay. Now these two values add up to 19. So if I add that on to the smallest value for x, I get 24. And if I add this on to the largest value of x, I get 38. So that's what the perimeter could be between these two values, 24 and 38. So what numbers exist between 24 and 38? That would be 31. All right, you don't want to pick 24 because it's not equal to, right? And you don't want to pick 38 because it's not equal to. Watch out for that. It's just 31. Done. All right, and we have B. Two sides of a triangle measure 14 and 9. Which of the following cannot be the perimeter of the triangle? Cannot. All right, so pretty much the same setup here. We have 14 plus 9 is greater than x. Then I have x plus 9 is greater than 14. Then I have x plus 14 is greater than 9. All right, so I'm going to have 23 is greater than x, or x is less than 23. Here I'm going to subtract 9, and I have x is greater than 5. And here I subtract 14, and I have x is greater than negative 5. Don't want to deal with the negative scenario, so x is going to be between 5 and 23. All right, for the perimeter now, if I add these two values together, I get 23. Okay, if I add that on to the smallest value, I get 28. If I add this on to the largest value, I get 46. So the perimeter has to be between 28 and 46. Okay, 37 is between those. 41 is between those. Well, 28 is not between, and neither is 46. So I don't know what's going on here. I got to change the numbers here. But both of these don't work, all right? So these two numbers cannot be the side lengths of the triangle, or the perimeters of the triangle. Alrighty, and that's all there is to it. If you have any questions, please let me know. Begin the assignment.